what we are looking at today is, our objective is to use trigonometry, and we are going to use the area of a triangle, which is going to be my first question of what we might possibly need to find the area of a polygon, to find polygons that you guys have not have done before. So really quickly, just kind of popcorn the answers out there. What areas do you guys know how to find? What shapes? Okay, you got a square, you got a triangle,
Rectangle.
you have a circle, rhombus, and a rectangle, and a parallelogram, and a square, all the same, right? Based on size.
Yes.
And you have a kite, right? Kite and rhombus can be found the same way. Rhombus can also be found as a parallelogram. Have you ever found the area of a pentagon?
No.
Have you ever found the area of a hexagon?
No.
Anything higher than a four-sided figure?
No.
So what we need to do then is break a figure that has more than four sides down into a shape that we've dealt with before. Alright, the first shape we're going to look at is the pentagon. I'll do my best to draw a regular pentagon for you. And again, we are strictly looking at regular pentagons because they are just easier. And that is not a regular pentagon. Alright, let's say this regular pentagon has a side of 8 centimeters. That's the way the problem would be presented to you. Find the area. One length, there's the shape, and it's regular. So let's start thinking about different things that we know for sure about a regular polygon, just regular in general. Here.
The sides of the legs are equal.
All the sides are the same, right? So all of these are 8. Anything else we know about a regular?
The angle's the same?
All the angles are the same. Okay? So every single one of these angles are the same. Now, we did do a formula to find out what the sum of the interior angles are before. We're not going to do that today. It has no bearing on what we're going to do. It's not going to help us, so I'm not going to waste your time. However, I am going to state that another thing that I believe I mentioned in the previous part of the year, all regular polygons can be inscribed into a circle. Do you guys remember that?
Yeah.
Yes.
All right. So this is going to be a one-time deal. If you drew it perfectly, you should be able to draw a circle hitting all vertices. And obviously that's not a perfect circle, so I didn't draw a perfect polygon. But if I find the center of that circle and then I ask you, what is that on the circle? That's the radius. What is true about the measurements of each and every radius inside the circle?
They are the same.
They're going to be the same. So if I draw this one and this one just because I want to work with that, and you already told me that that is 8 centimeters because that's the distance. What is starting to happen? What am I creating?
Triangles.
Do you know how to find the area of a triangle?
Yes.
So that's one thing I need you to recall. Area of a triangle is what?
Right.
1/2 base. Okay? That is one thing we have to be able to recall. Now, what we have to also be able to do is find what is called the central angle. Anyone think they can figure out what the measurement of each of these angles are that I'm figuring out as I finish off the Chrysler symbol? How would you find the measurement of each of these angles? 360 divided by 5. That is how you find the measurement of any central angle in a polygon. Is 360 divided by how many sides it has. This time it happens to be 5, which means that our central angles all measure what?
72 degrees.
72 degrees. Alright, we just talked also that the radiuses are the same. Correct? So that means this is an isosceles triangle. Think back to isosceles triangle. What happens when I draw in, I don't know, say the height of that triangle? What happens to this angle? What happens to this side? You divide them both by 2 because the height is going to be bisecting both of them. So what's half of 72?
36.
Perfect. 36. And what's half of 8? 4 centimeters. I'm going to pull this triangle out so that we can look at it more carefully and see if we can figure out, because right now, don't we have our base that we need for our area of triangle? But we don't have our height, right? So, if I draw this triangle a little bit bigger so we can look at it better, and you guys told me this is 36 degrees. You told me that this is 4 centimeters. You told me that that is a right angle. And we're looking for the height. Is there anything that we might have used, I don't know, in the last 2 to 3 weeks that would help us figure out what is h?
Pythagorean theorem.
All right, how are you going to use Pythagorean's theorem if you don't have
Okay.
one of the sides?
Right.
We're on the right path. It's some kind of right triangle geometry. SOHCAHTOA. Now, one of these trig functions is going to help us. Which one is it? Alright, which trig function? There's 3 trig functions, right? We have sine, cosine, and tangent. Which one's going to help? That's what Okay, look at what you have. First thing we always start with is finding the what?
The hypotenuse.
Not the hypotenuse.
The angle.
The angle. We find the angle. Then we look at what we have in comparison to the angle. I go straight across from the angle, I have the
Short side.
opposite, remember, O. And then H is what? In this case, I'm sorry that we're using that for height. That's the adjacent side, right? Since it's not across from the right angle. So now we have to use TOA, so opposite and adjacent. Now think about how we just drew this triangle. Do you possibly maybe believe that that's the only trig function that's going to happen? Because you have the opposite and you draw an angle in, you have the angle, you're going to have the base, then you're looking for the height. Isn't that the way it always is going to be? So this is the trig function we need. You're going to be using the tangent. For all of them. Okay? Unless you see a shortcut, which hopefully, as we go on to our other examples, I'll show you a couple of shortcuts. Alright, so we want the tangent to find h. So remember, to set that up, we go to the tangent of 36 is equal to opposite, which is 4, over the over the adjacent, which is h. Okay? Now, with that being said, what do we do to solve from here when h is on the bottom? We're going to divide, right? So we're going to swap this out. So h is now equal to 4 divided by the tangent of 36. Alright. We should now have everything that we need to find the area of a triangle. Okay? Because we need base. What's our base of our triangle?
4.
And now the height is 4 divided by the tangent of 36, right? And we're just going to take half that. So what we're going to do is we're going to keep a running total of all of this on our calculator because we have 1/2 times 4 times h, which I'll show you guys how we just keep that going. Okay? So on your calculators, what you want to do is you want to take 4 divided by the tangent of 36. Okay? You should get 5.5. Then times 4. And then divide by 2. Now that is just the area of that triangle. What we want is the area of the pentagon.
Oh,
Yes, ma'am.
didn't you find the answer of that one and then multiply that answer by 9?
Not by 9.
Because
How many triangles are there going to be?
Well,
1,
that's just
2,
the half,
3,
though, right?
4, 5, 6, 7, 8, 9, 10. Now, what's a faster way to find out how many triangles are going to be on the inside? That's simply 2 divided by the number of sides. Okay? Questions? So again, that's 2 times the sides, which is 2 times 5, which gives you 10. Because you have this one plus 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 this one, which is over 10. So 10 times your area, which means that you guys should be getting the area to be approximately 110.1 centimeters squared. Is that what you guys got on your calculators?
Yeah.
Alright. So, what I'm going to do now is we are going to draw up a hexagon, and then I need you guys to tell me what to do. Okay? Anybody still writing this for notes before I take it off? Okay. hexagon. We're not going to deal with the circle this time because you all understand that we're talking about a radius. Alright, let's pretend that that's a regular hexagon even though it's not. And we got a 10-inch dot. How do I find the area? What do I want to create first? Do you know how to find the area of a hexagon? No. But you do know how to find the area of a
Triangle.
so let's make it triangle. You got a question, Brandon?
Never mind.
Never mind.